So there's been some conversation recently about using hair straighteners for folding holster shells. I love hair straighteners for that, so here's a breakdown of a lot of the details of how our folding process works. The first thing you'll notice is that this is not a big, complicated, dedicated system. This is on a little stand. I've got a little cooling fan. This setup is mobile. I can put it almost anywhere in the shop that I need. It normally lives here on this bench, but we can take it over to any other table or bench in the shop. And if I have somebody running a CNC machine and they've got a minute and a half free while the CNC is running every cycle, this whole setup can go over there and they can do productive work instead of standing around twiddling their thumbs while the machine runs. So this is a Conair Infinity Pro. It's got a long heating element and it's 1 inch wide. I like hair straighteners in that they give me a very consistent width and length of heated area, and they're relatively fast because you're heating from both sides of the sheet. We always heat with the texture side facing up, and we have a Teflon wrap on our top element so that we don't mess up the texture on the material. Things that hair straighteners are great for are consistent folds where you've got plenty of clearance to get the hair straightener into the channel. So an example would be this holster, which has a nice clear channel with no blocking or other things in it, is ideal for hair straightener folding. We just put it in there, toggle clamp holds it closed. You can watch the sides relax. It's not on right now, I'm not live folding. You can watch the sides relax and then take it out, put it around a folding slug, and then you're ready to cool it. The way that we actually cool things is with this little guy. I've seen lots of other different ways. Some guys like to stand there with compressed air. We do that occasionally. It's loud, it takes up time, and the person is standing there just holding it. What we can do here is put a couple of spring clamps on a part and then throw it here. So we've got this little Kydex U shape here that holds this upright with the hot channel facing down toward the fan, and it just keeps blowing until it's cool, and then you can take that out, put the next one in. That allows us to have one in the iron, one on the cooling fan, and have the person doing the folding have a little workflow here instead of having them do one thing at a time and have nothing else happening. Things the hair straightener is not great for, if you have a channel that's longer than your heating element. I don't like folding large light-bearing holsters on a strip heater, on a hair straightener. We do them on a strip heater because I don't want to have to heat part of the length here and then take it out and flip it and heat the other end of the length and have to chase that around. That's a hassle. Strip heaters are great for that. The other things strip heaters are good for are if you have a channel that's partially obstructed. This holster has got wedges that come out into the channel. It's got RMR guard blocking. It's got a few things that could interfere with you closing your flat iron. In this case, the channel is wide enough that this particular holster will still work on the flat iron, but not all holsters will. Back in the day, we used to put a lot of our tuckable overhook blocking off the corner of the slide out into the sight channel, and that interfered with how we heated things. We had to use a strip heater because I couldn't get a flat iron into that space. We use 3D printed folding slugs. I'm a huge advocate for test fitting everything with real steel, so we do that. Everything gets 100% test fit with real steel, but real steel is not an optimal folding drone. The reason is there's always some dead space. There are going to be unsupported areas under the shell. And if you're applying clamping pressure and there isn't a countercall inside to support the shell, you can bend or deflect the shell and get inconsistent results. For the same reason, this allows us to use clamps and not rely on feel or hand pressure, and that means if I have two different employees and they're using the same clamps, I'm going to get more consistent pressure on the fold than if I had those two employees doing it by hand by feel. Even if they're both good, they're not going to be exactly the same. So, a few things on our 3D printed folding slugs. We run these on our Raise 3D printer in-house. I undersize them in a few key places and we add some aluminum tape just to protect that part of the 3D drone from the heat of folding. We fill in and cut away the front of the trigger guard so that they can slide out of the closed shell without having to overcome the passive retention that's built into the holster, because the 3D printed drones are not designed to deal with that kind of wear. We print them pretty lightweight with only an 8 or 10% fill because they don't need to be able to withstand a lot of pressure, and the drone itself is not actually being exposed to that much heat because the heated center is floating up in the air here above the drone and is not touching the drone. You'll notice I do not have a sight channel printed on here. I don't have a dowel taped in place. I have nothing like that. I don't use them. If you 3D print a sight channel that's supposed to closely conform to the inside of the holster shell, you'll pretty quickly find that the heat of that folded area will soften your 3D printed material, because this is thermoplastic also, and you'll gradually distort that channel. We've experimented with adding channels using wood or metal or other non-thermoplastics, and I generally find the juice is not worth the squeeze. But we do use, for folding, we use a little machined hard channel. And this is product specific for different OEM things we make, or for our products, we have different widths and depths of channels that we have dialed in exactly for that product so that we can get a consistent fold every time. So my iron is hot now. I'm going to do a fold on one of these new Filster Pro Series holsters. This is for the Glock 48, so I've got my Glock 48 folding drone. It's got blocking to support the shell. Every place the shell needs to be supported. But the 3D printed drone has you'll notice there's no wedge on the drone. Anything that's a raised area inside the perimeter of the shell, when you fold it shut, that would be captured by the Kydex and would make it a lot harder. I do not want to have to fight this drone back out of the shell. So we fully support the slide, the frame, the dust cover, the trigger guard, but we don't build on tuckable blocking or anything else that would be a protrusion further down inside the holster shell. So I'm going to go ahead and just throw this on here, close my iron, and it will gradually heat up and relax. Since this is a fixed retention holster, I'm going to go ahead and throw one eyelet in just to ensure my alignment is good. It's already starting to relax. This process is fast. I do not have ear pro or eye pro in. I'm not going to be using compressed air for this. Sometimes I would, depending on my mood. So take this out, fold it around our 3D printed drone, press that eyelet through, throw a clamp on the front, clamp up here, and this is ready to go on our cooling fan. Okay. I could, if I was concerned about the shape of the channel, also use the hard channel to press in here, especially if I had a holster shape where the tip of the channel was tending to dive down or curl up. This is really good for taking that little bit of deformation out, and you just let it have a couple of seconds to start to firm up, and then you go to the cooling fan. So this would go to the cooling fan. The clamps in this U-shaped channel keep it upright, and then the next one would already be on the heater. I normally would have multiple copies of the folding drone, and that way the person doing folding can be feeding parts through the process and not have to stand there with one part in their hand and get it all the way cool and then set it down and start heating the next part. So having overlapping things going makes the whole thing faster. But if you have a channel that's narrower than 1 inch and this can't get in here, you're not necessarily stuck. We use a flat iron for folding all of our magazine carriers, and those have a very tight, very narrow channel. So I designed and built this little guy that fits right on the lower element. This process is a little slower because we have bottom heat only, but you basically touch that little jig against the inside of your channel until it's soft enough to then fold around a 3D printed magazine slug. Same thing, we're fully supported on all surfaces. We put this in, fold it shut, throw a clamp on, drop it on our cooling fan. I really like flat irons. I like having them have a consistent pressure. I really like having a toggle clamp on them. I like having it on a stand, so I'm not having to mess with holding it closed or taking a clamp on and off. This is really simple. It's easy and cheap to build. The flat iron's about 40 bucks, and it works great. We can move it anywhere in the shop. It's flexible for a bunch of different products. You can modify it with little add-on jigs to change the heated area, and it gives us great results day in, day out. We use it all the time. So I actually just bought a couple more. We're going to tool up a couple more stations for this so that I can have one that's dedicated for prototyping, one dedicated for production, and then a third setup that can go anywhere in the shop we need it as we have use for piecework while we're running CNC machines and the like. So hard channels are great. 3D printed folding slugs, if you do them correctly, provide awesome benefits. I know some other companies use 3D machined folding slugs, which is super cool. I don't want to tie up my machines for that. Being able to take this file and throw it on my 3D printer and run it during the day or run it overnight and have it not interfere with anything else that I'm doing is really valuable to me. And once I've got the program done, there's no fixturing, there's no tooling. I print one, it's good. I need more of those. I just print 2 more of them, and then we're ready to go into production. So that's how we use a flat iron for folding. Hit me up in the comments if you have any questions or there's anything else you want to know about the process. I'll give you the best answers I can. Thanks.